Hi, everyone. This is Ram Vedam speaking to you live from Atlanta. And this is welcome to the one second.
Hello?
Yeah, welcome to the AFP Common Lisp Virtual Study Meetup. Apologize early on when this is my first setup through YouTube Live, so I'm dealing with some logistics, trying different things in different browser windows. So I was repeating myself over a different window, so I wanted to close off everything. Today, we'll be covering Chapter 4 through Chapter 6 of Practical Common Lisp. I hope those of you who are joining us had a chance to at least review some of this material. Could I just get a sort of a feel of those who are actually here live, if you had a chance to review chapters 4 through chapter 6? Excellent.
Not as completely as I'd like to, but yeah, I did look at it.
Oh, excellent. So, hi, Tanju. I was just kind of asking around if everyone sort of had a chance to review chapters 4 through chapter 6 of Practical Common Lisp, if you had a chance.
I did not. Yeah, unfortunately, I did not.
Okay, so that's okay because we will go through some of this material. The main things to start about is really chapter 4 is a very important chapter because it gives you a nice overview of the Lisp philosophy of what Lisp's syntax is, why the syntax ended up becoming just S expressions. It actually has a direct quote from John McCarthy himself when he started designing the algol-like syntax, the M expression syntax. It became quickly abandoned, and since there was no real future goal as to when the syntax should be designed and when it should be done. By the time that they sort of had a good idea for it, S expressions sort of just been accepted to be the best way to write Lisp code. The other thing that was kind of interesting about this particular chapter, chapter 4, that is for those of you who aren't familiar with programming languages and compilers, it gives a nice very brief, but very precise overview of what a compiler does and how systems are typically designed for taking a source language that is usually probably within fixed notation or statically typed or something like that, like Pascal or Python. And it'll go through a series of transformations before it'll eventually become executable code on a machine. The thing about that traditional approach and Common Lisp's approach, and other more experienced Lispers that are on the call can correct me if my understanding is incorrect on this. And the Lisp approach versus the traditional approach is Lisp you're almost directly interacting with what I would say is an equivalent to the abstract syntax tree itself. So it's almost as if you went through the parser already and you're dealing with just an AST and you're manipulating transformations directly. This gives you some advantages, of course, because then you can actually use the same parser that's used to read in Lisp objects that are in your interpreter in your REPL, and it will go ahead and it'll go ahead and allow you to generate new code that is essentially Lisp as well. You can also use Lisp as a data format, and you saw that in chapter 3 if you guys went through the CD tutorial, because the CD database that Peter Seibel makes you essentially design, that's a plist, it's directly written to file. and it is read in as if it's the same, data structure. It didn't have to go through any sort of intermediate serialization process. And in fact, if you look at that text file itself, you'll end up realizing that it is just an S expression. That is what was built into the Lisp memory was dumped out to a file. So this it gives you an immense power to actually design a language that, as long as you end up bringing it to a Lisp object, and you have a set of functions that could do transformations on that structure, you can make a really quick compiler on a very simple language, or even create good programming language compilers just using something called syntax-directed translation, where you basically take your source language, convert it to Lisp objects, and then run it through eval, your own custom eval, where once it sees some syntax of a particular type, it will go and call up a function that will execute for you. Of course, you can also build traditional compilers on this, but the book doesn't go into that, and that is a complex topic itself. Later on in the study group, if people are interested, we could certainly build that too.
Do you know if there are any resources that cover material like that, like any books or anything?
Yes, good question, Michael. The best book that I'm aware of that is recommended for people who want to implement Lisp and Lisp-style compilers is Lisp in Small Pieces by Christian Koenig. I think it's his last name. He's a person in the INRIA. He actually wrote a very nice, thorough book on how to implement a Lisp compiler, and how Lisp transformations work in general. And what's interesting about that book is if you actually go through it cover to cover, you actually end up with a Lisp compiler. He used an approach called literate programming, where he essentially mixed in documentation and source code. So if you copy that source code in, eventually, by the end of the book, you will have a practical Lisp implementation running, and it'll teach you a lot of the transformations along the way. But yes, that is probably one of the best ones that I can recommend. Of course, there's a bunch of tutorials online that shows you how to create Lisps, even in like Python. I think the best one that's known for me, if I mention to people about Lisp interpreters, is Peter Norvig's Lisp that he wrote in 90 lines of Python. There is a 2-part series that he built on teaching about Lisp and how easy it is to actually build up a Lisp interpreter, and even add full scheme semantics. I will, at the end of this talk, post on the meetup some additional reference material related to that. But if you want to Google it now, Peter Norvig's Lisp interpreter in Python, lisp.py, is a good resource that will go through that material.
Yeah, I know. I've seen that stuff before, and I know Lisp in Small Pieces is written in Scheme. So I was just wondering if you knew of any like common Lisp items like that. I think ABC. It's called ABCs of Lisp or something. It's like a very old common Lisp book from like late 80s or early 90s. I think that has something like that, but you don't see many people talking about that book, so I don't know how good it is.
The concepts from Lisp in Small Pieces, and this is just one comment on Lisp in Small Pieces and Lisps in general, the approaches that are taken in there can be applied to the development of a common Lisp compiler in a pretty straightforward way. One thing that you would have to be careful of, and this is where the common Lisp hyperspec will become a really good use, and especially in its understanding of the semantics of the common Lisp standard, is how do you implement the function namespace semantics that are not actually in Scheme, but is necessary for common Lisp, especially when you start trying to design and compile like stuff for def macro, because and we'll touch base on this when we start talking about macros. Common Lisp macro system is different than Scheme's macro system, and the distinct difference requires understanding what macros are and how code transformations work, and where Common Lisp solves a problem called name collisions and symbol lookup, because there's a specific approach that Common Lisp takes when it's shadowing symbols that with macros, its approach is much different than Scheme's because it has a separate spaces for functions versus variables. But that being said, anybody who talks about any Lisp, whether it's Racket or Scheme or Clojure or Common Lisp, a lot of them, at least from my research into looking for how to build a Lisp implementation, always point to Lisp in small pieces. So I think that's a good evidence that at least to take a look at the book and see where it ends up, breaking down for Common Lisp and then adjusting that with the Common Lisp Piper spec. But you'll get pretty far in the book before you actually need to address that issue. One thing to note here, and this is something that I find particular, I forgot about this when I went through this the first time, but I think people will get a kick out of this is the section on special operators in Chapter 4. Special operators, of course, are because of S expressions. Let me take a step back and explain S expressions in relation to function calls and where special operators play into place. Since S expressions is such a simple thing, it's just a list. The evaluation rule for dealing with functions in Lisp is very straightforward. It's function name arguments as well, and it has to be encapsulated within parentheses. Otherwise, of course, you'll get an error. And if you don't want something to be evaluated, there's a special operator called the quote operator that will essentially tell the Lisp REPL not to evaluate the particular piece of code that you stuck inside the REPL itself. One of the side benefits of this is of course with the quote operator, and I'm starting with quote. The book, this section on special operators starts with Lisp. Regardless, these operators are basically things that cannot be actually addressed directly by a function call and cannot be addressed with function call semantics, because function call semantics is particularly important, especially at things like the assembler level, because what a function call really means, especially when you compile it, is very, very precise. It generates a scope. It'll put arguments onto the stack, and it'll then evaluate your forms. But it can't deal with conditionals that way, of course, unless you do something called a conditional goto, which is essentially a branch at the assembly level. So Lisp was one of the first programming languages that actually had the if statement in there. And if is an operator that has specific generation instructions inside the Lisp REPL. And if is one of 25 special operators inside the Common Lisp language. It's funny because of the fact that these are, I think Go is a language that has about 27 keywords, reserved keywords for this, and everything else is built on top of those 27 reserved keywords. But in Common Lisp, there are 25. And then there's a huge library about maybe 700, 800 functions that are built on. So you could think of the core Common Lisp language, if you really wanted to be very precise about it, has these 25 special operators with the arithmetic operators, and then this massive standard library that needs to be implemented on top of these to constitute the base Common Lisp language. And then, of course, other standards that are built on top of that will be provided on there, has a lot third-party libraries or extensions inside the Common Lisp implementation that are using. We won't go through all the 25 operators here because the rest of the book will go through it in due time if and when they're needed. But chapter 4 does two more things. One, it talks briefly about macros. I'm going to ignore that for a minute just because macros is a very detailed discussion that we will have when we get there. There is definitely a lot to talk about with macros. But the more important thing that's in this chapter that really we should discuss is the notion of equality. And I would like, some feedback from other Lispers who, from their experience. Judd, feel free to chime in when I'm making a mistake here. But in short, Lisp has several levels of truthiness, if you will. There is a canonical truth value in Lisp. Nil is basically false. But in terms of testing this truthiness, you have different ways of testing it. There are 4 different styles of equality. One is EQ, then EQL, then equal and equal P, and we'll go through each of these. On top of this, I just want to mention that there's things like helper functions like string equal, character equal, and so forth, that you will probably use more often than some of these equality tests. But be aware of these equality tests. One, in terms of discrimination, EQ is almost has higher precedence than EQL, and then EQL has precedence over equal, and then equal P is the lowest precedent equality operator that's around there. What does that mean? EQ deals with essentially the pointers, and make sure that 2 objects are exactly identical. And this is really implementation dependent from what Practical Common Lisp talks about, as well as other Lisp books that might be available. Another one with EQL, EQL behaves like EQ for object identity and equality, but it checks if they're first the same type, and then deals with the equality operator. So like if you do like integer equals using EQL, it'll check their types, and then if they're not the same type, it'll print out false. So if you do like EQL 1 and 1.0, there's a difference between that and EQL 1 and 1. To illustrate this, I will let me just share my screen here, my Emacs session, and I will show the difference here because I think it's important for equality. Now, I'm going to be upfront. I am currently using CCL, that's Closure Common Lisp, for this. So Semantics is a little different than SBCL, Steel Bank, for EQ, but for EQL, it should be fundamentally the same. So you can see here, EQL gives you correct equality for integers, but if you do an integer and a double precision or floating point precision, it'll automatically print out nil. This is a little, for folks who are used to languages like Python and C++ and languages where they essentially take a number, a numeric, and convert it to the appropriate type before doing the comparison. This might look a little off-putting or a little different, and probably even in some cases jarring. But you'll get used to this kind of thing because it's doing an explicit type check before it actually does that. And in a lot of cases, there are some advantages of this, and we'll address that, as time goes on. The other 2 objects, the 2 equality operators, equal and equal P, they're basically the same. I almost often use equal when I'm dealing with strings instead of string equal, but you can use string equal as just as well too. But they're very generic in terms of how they deal with comparisons. You can also define your own predicate equality functions when you're dealing with objects, and when we're dealing with the common Lisp object system, we will touch base on that. The final section on chapter 4 in a very quickly is just on compiling, formatting Lisp code. I do encourage those of you who haven't checked out this chapter, pay particular attention towards the end, because Peter Seibel and the Common Lisp, the Slime quick reference card do give you a key binding that you could just use to automatically format your Lisp code while you're editing. So it gives you some ability to quickly type in code, and then when you're ready and you want to edit the format the code, you can just call this key binding and it'll format it for you. Any questions? Judd, did I miss anything? You're on mute.
No, I think it's fine. Yeah, I followed so far.
Sweet.
I tested it out. Yeah, I tested out in at least SBCL. Set x equal to 1, and then test to see if 1 and x are EQ, and they are.
Okay.
So I'm going to unmute now.
Okay, that's good. All right. So the next thing on the is chapter 5, which is all about functions, and this is this definitely for folks who are used to using things like Python and Ruby. It might be different because I don't think keyword arguments and REST arguments and optional arguments work the same way. Well, I don't even think Python has optional arguments, if I'm not mistaken. It has default arguments. So that is something to be somewhat just be warned. There's some features in here that if you haven't touched in a language that has these features, you'll get some getting used to, because the rules on mixing them and matching them are very, very distinct, and there are some places where there's undefined behavior. The chapter does go through those situations, and I will touch base them here, but I want to give you a heads up about this, because the first time I learned about this, it was a little off-putting, just because I wasn't so familiar with it. So let's try a simple add function, right? We all know this one. We can actually build add expressions, add functions that will take in 2 arguments. Okay, if you wanted to do, let's say, a simple sum function, you could also use something called a rest parameter that will take in a bunch of arguments, and then you can just loop through them, and it will allow you to, it'll quickly generate the list for you, just like var args in like C or C++, or args, like star args in Python will also give you sort of the same thing. The other thing is keyword arguments, which is kind of those of you who are familiar with Objective-C, this will definitely look familiar to you, because Objective-C has sort of this notion of message passing with keyword arguments a lot. Although in C++ folks, you may not be familiar with it, and I don't know. Python's notation for keyword arguments is a little bit different. And right now, it's kind of evading it. I'm forgetting it off the top of my head. So an example of making a dumb user, we could say keyword arguments, name, age, occupation, and then we could just make a dumb list here that will that will then allow us to then use, if we just do, we don't pass in any arguments, you'll see that they're nil, 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 and we'll then be able to, and without, in any order, you can actually specify your arguments, and it will go ahead and take them and bind them to the appropriate places. So this is something kind of interesting for those of you who aren't familiar with this. And again, this is for folks who are not used to this ability to be able to switch between arguments and stuff. I don't recommend doing that. Just my personal opinion on this, just because when I'm looking at code, it's kind of nice to be able to match the keywords to the signature. But that's just because I'm still used to like doing this in other languages. But it's just a personal preference. But this feature is available for those of you. Again, to quickly review, keyword arguments bind their values to a particular thing that's passed in to something, and they can be bound to any value in any order, and it will still execute the code in the same order regardless. And if you pass in, if you call a function with no keyword arguments, even though you have keyword arguments, those arguments are set to nil by default. Of course, you can set these guys to default parameters, but that is just the common notation, regardless of Lisp. I'm almost certain SBCL and ECL and all the other Lisps that are out there follow the same behavior in terms of keyword arguments. It brings us to optional arguments. Optional arguments are basically, I don't have to really go say anything much other than they're optional. You don't have to necessarily specify them. If we do a foo and pass in, this is the textbook example of this, and I really do mean that it's in the textbook. There's a function that has two optional arguments. If you pass, on none of the optional arguments, it'll go ahead and set them to nil, much like our keyword argument default. If you obviously, if you set them all four of them, it'll go ahead and bind them appropriately, just like before. The other thing about this is, and the reason I started with rest, then key, and then optional, is because the mixture of these is a little bit. You just got to remember these rules about mixing these parameter types. Specifically, you can mix required parameters. Required parameters are something that doesn't have. Let's say foo2. These are required, of course. If you don't pass in, these, you'll end up getting an error. You'll end up getting an error saying that it's like requiring two arguments, but we passed in 0. That's what this error message is saying. And with that, you can actually, like this example that I showed you earlier with make user, with foo. Here you can see that you could pass in optional and required parameters. You can also make this into rest, and if you just do foo 1, 2, 3, 4, 5, you'll see that the last 3 arguments that were passed here are just combined into a list and then returned as part of the object. But if you tried to mix optional and rest, or optional with key, depending upon how you did it, you will have undefined. You will have differing behavior. And And the book has a great example of this that I'm going to just show you. Let's create a function that has an optional keyword and a keyword parameter called z. All right. So now, and we're just returning a list again. Now, if we do if we call this with all three values, you'll see all the list getting appropriately bound to those values, those arguments. But if you pass in just one, because one is a requirement, it's going to say that, oh, sorry, wrong argument. If you call bar with one argument, you'll see that the optional argument and keyword argument don't work. But let's say that you want to bind one and then set the keyword argument to a value, which means optional. Since y is optional, it should be nil, right? You'll end up getting an error because the keyword that you thought that you were passing in, this z, was actually bound to the y variable. Okay, so your x, y, and z is now 1 colon z. So I'll just write this as a comment. X here will be 1, y here will be z, and z is undefined. And since z is undefined, you're passing in a third parameter. The REPL is evaluating this and saying, well, you didn't pass in the keyword parameter, and it will throw up an error saying that you're trying to bind a value to a parameter that requires the keyword in order to be bound. I know that that's a very long-winded explanation on this, but it's very important to understand that that optional and key and optional rest have some very precise semantics. So those of you who are not used to this, if you have questions, please, ask them on this, just because this will become a source of problems as you become more and more serious on developing Lisp applications. So understanding this function call piece is somewhat important. Cool.
I have a question, not about the parameters, but actually, well, about something he did in chapter 3. So when he was removing, using remove if and remove if not, and he was passing in a first order function, he was using sharp quote because he was passing in even p, but then he was also using sharp quote when he was defining a lambda. I don't need to necessarily use a sharp quote when defining a lambda, so I didn't know why he did that, or because it doesn't even seem like it's the same thing. One is doing a lookup for a binding, and the other one's defining a lambda. Do you have any clarity on that?
So you're asking about in chapter 3 the notation of defining an anonymous function when you're calling remove if not, correct?
Right. Yeah. So if I'm using even p, right, you have to prefix that with a sharp quote.
Right. That's correct.
But he also does that with the lambda, which I don't think is necessary, but I'm not sure because it works without it.
It's not technically necessary, but sharp quote is a shorthand for function. If I'm not mistaken, I've just gotta.
Yeah, that's right.
I think so. I don't believe. I think that's correct what you're saying. I mean, we could just try that right now. Fun call lambda x to double and pass in. Am I still sharing? Yeah, I am still sharing my screen. Okay, pass in 1. You can see, fun call behind the scenes. Those removes if not ends up doing like an apply or a fun call. So yes, technically, what you're saying is correct. You don't need to do this, but it's a convention that makes it blatantly obvious from looking at the Lisp code that you're passing in a function as an argument. It's just a notation at that point with anonymous functions. With named functions, of course, you do want to do that because it is doing. I don't think actually in the case of fun call and apply, I don't think it matters. But in terms of remove if and remove if not, and some of those higher order functions, I think it does matter. So if we do even p here, oh, okay. So it does. I take that back. This is, you are right that this needs to be there. So sharp quote is important for named functions because it does a symbol lookup, and then for anonymous functions it doesn't matter, but it's a notation that most people just adopt. I haven't seen a situation where most people do not adopt that convention.
Okay, good to know.
Just wanted to chime in if you guys can hear me.
Sure, yes, I can hear you.
Okay, cool. Okay, I've been having trouble with the Hangouts, but anyway, I wanted to chime in on the sharp quote. So the reason it's not necessary, it's a little complicated looking at like the lambda form itself, but essentially lambda is actually a macro that stands for sharp quote lambda or function lambda. So that's why it's not necessary in most situations. So the sharp quote is, there's a big stylistic reason for using sharp quote before lambda or not using it. So you'll get either one. In grand majority of cases, it's equivalent. Just because the macro expands into a function lambda.
Does that make sense, Michael?
Yeah, no, that's interesting. I didn't know that.
There's a lot of interesting things that we'll end up realizing that some things that are those macros end up or something that look like functions end up being macros that will generate quite significant code. But I'm trying to hold off on those interesting discussions until we get to macros, just primarily because that is a involved subject, and I just want to make sure that the folks that are learning this are at least familiar with the syntax a little bit to embrace some of these discussions and start experimenting a little bit more. And function call semantics in Common Lisp tend to, at least with respect to like chapter 5's introduction to optional and rest and keyword parameters, understanding those really will help you in later chapters as you explore more the language. So very quickly, so we can get into some really interesting stuff. Notion about, because we were talking about anonymous functions, most of you just saw some examples of calling anonymous functions using fun call. Another way of actually doing anonymous functions in evaluation is to do like a lambda calculus style, here's an anonymous function, and then pass in the values of the anonymous functions, which will bound those values. So it's the equivalent of actually a named function lookup. What it's really good use for is obviously higher order functions, which I'll just touch base here with the map. Although we haven't got to map just yet because we haven't touched collections, but map is a great example of using a higher order function. And just iterating through a collection, and it will output another collection. You can see this is here. This is very simple. You'll just iterate through this list. You can actually implement this yourself using one of the iteration constructs that we will go through later on, like do times and do list. But the real value of this is it brings up the layer of abstraction to a way where you're now dealing with the data structure and its iteration semantics, and generalizing the core abstraction of the algorithmic abstraction to its bare primitives. So you'll have a generic algorithm. So this is one of the inspirations behind a lot of generic programming and parametric polymorphism that's inside the Ada generics library, as well as the C++ standard template library. If you look at Stepanov's works. And as we get more and more into higher order functions and functional programming, you'll end up realizing that while it is possible to do some mutability in Common Lisp, the majority of the code does encourage a more functional style of programming. Finally, and again, we've touched functions as data as being available. We've touched apply and func call a little bit, and I encourage you guys to go through chapter 5 to see more examples of this. But the more important things is chapter 6, which is variables. But at this point, I've talked a little bit about this. I talked, through chapter 4 and chapter 5, and I'm gonna put the floor to, some discussion if you guys are, have you guys experienced, those of you who are using other programming languages, using Python's higher order functions or C++'s higher order functions? Have you guys used any of those features in those languages? I'm looking at Tanju. Have you touched Python at all? I don't recall.
No, practically no. I'd say barely.
Okay.
Definitely haven't written my own code, unfortunately.
Okay, cool. James, I'm kind of curious. Have you done anything with the higher order functions inside Python or C++ or anything like that? Like,
I've used functional programming, and I tend to use a very Lisp style of Python, oddly enough. So yeah, I've used closures, used higher order programming. To use objects. I'm not a big fan of classes.
So
if I do functional programming and then add sort of interface, pretty nice in Python. So
cool. So you're talking about using like func tools in Python and iterators correctly the way they were intended. Yeah, you're kind of breaking up, James. So for those of you who are listening to this, for the reason I bring it up is Lisp, a Python style higher order functions and its behavior is very, very similar. So those of you coming from that space, you will be right at home with a lot of the stuff that is here. The syntactic differences is the only thing that will probably, make you step back and think about it. But other people coming from, say, C++, who are doing functional programming, especially now with C++ 11 and 14 having these features. In the early days of C++, I will say that you could have sort of get the same idea if you created something called a function object or a functor, and then pass it into the standard template library. That's actually how it was originally designed. But nowadays, you can just pass in a proper anonymous function to, say, transform, and you'll have a very functional style of dealing with collections. So now you have a library of algorithms, and you have a library of data structures with very distinct memory layout and memory access semantics that the algorithms are completely unaware of. as long as the appropriate operators are implemented in the interfaces to these collections, and the data objects that are there have the appropriate semantics, you could just use these generic algorithms as is on these sequence containers. And it's really, really useful for those of you who are creating, pretty large scale systems, because it does provide you a different type of abstraction that object orientation does not provide. It's a different design approach. So finally, chapter 6 is introducing to folks who aren't, familiar with dynamically typed languages, Lisp's notion of, what is variables inside a program, and particularly most programs, variables are basically of typed object. Python is this case. Technically, and I'm talking about dynamically typed languages that are currently in use. So Python and Ruby's are, those are technically of typed object. You can hold any object in there. It could be a string, it could be an int, and so forth. In Lisp, though, Lisp is two things. One, it is a dynamically typed. It is the type errors are checked at runtime when a function is being evaluated, and Lisp is also strongly typed. That is, you cannot take an object and cast it to something that it's not without getting some sort of crazy type error. I haven't at least seen any particular way of really doing this, and it's really a feature inside the language. It allows you to have strongly typed programs, and you'll get type warnings if you're trying to compile code that is, incorrectly typed, and it'll try to generalize it as much as it can to the error that it could have type mismatches when you're evaluating a particular function. There's two different ways of defining these types of variables. When you are starting with, and we saw, one of them essentially behind the scenes, which is inside the function. When we pass in a value here into this function, you will end up realizing that behind the scenes, what this does is, like the other traditional programming languages, this does what's called a let form. So the equivalent of this and is creating a lexically scoped environment, like say A, and we pass in ROM, and we type in hello. And we pass in the variable that we get evaluated. It gets evaluated to A is bound to ROM, and then format gets A has its parameter when you're actually doing for print formatting. Defun does the same thing. It has what's called and in fact we could see this if we do a macro expand on this, and I will for those of you who are going to get or who are probably saying, well, what's macro expand? It'll allow you to look at the expansion of how a function is getting macroed before evaluating it. So you can just defun A to a list A. And you can see, I don't know if you guys can see this. Let me try and maximize this and see if what this is doing is it's calling an end function boo lambda, which is creating a block behind the scenes. This block is essentially a lexically scoped piece of code that binds certain values, and it will then execute that code. In this case, the code is a lambda expression that's taking an argument, which itself behind the scenes is essentially a let. Of course, you will never see that in a macro expansion, but in how the code gets compiled, it's essentially the equivalent of what I just showed you before. The other way of doing things is sometimes you may want to, of course, have just a simple global variable, right? Lexically scoped values are pretty great for local variables that you will have inside of a function, or bits of code blocks that you're probably writing in scripting. But sometimes you may want a global variable that you're setting up. So in there, Lisp has something called special variables or dynamic variables. The way you would specify these is using def_var or def parameter, and there is a difference between them, and we'll just go through them quickly. Def_var doesn't necessarily need you to specify an initial value, okay? But def parameter, if you try doing this, and let's just say we specify it as another global var, you'll end up getting an error because def parameter expects some sort of initial value for the global variable that you're creating. So when you're using def parameter, and I often use def parameter more than def var just because the only time def var I've seen, at least for my own day-to-day coding, is when I start developing multi-threaded programs. I don't know about other experienced developers that are online, but def parameter was more useful when I'm creating a set of singleton values that are going to be utilized everywhere in a program. That's even in a non-multi-threaded case. And this notation here of def parameter or def var, name some initial value, you could say 01, and a comment is how you would normally see people who are creating code inside Common Lisp write their code, because you need to have a documentation. You'd want to have a documentation string to illustrate what this this variable is, or this code is. Particularly useful inside functions as well. I don't know if I went through this, but I'll just go through it again. You can specify a simple display function, and what you can then do is you can use a documentation string. Pass in the function, say that to look up the function, and if it has a doc string, it will just spit out the doc string for you. You can also specify variables to actually get the global variables as well. If I remember correctly, this is what was it? Was it variable? I think. No, yeah, it was variable, if I'm not mistaken. There is a way of querying your documentation strings on your global variables. Right now, it is eluding me. I will, look it up and get back to you guys on that. But the reason I bring it up is it's useful for folks when you're writing code. Now, with variables, one thing that's kind of cool here is you can create functions inside of a let scope that then gives you the ability to access that particular variable in the let scope. So essentially, it gives you the ability to write closures, which is this binding the context, and then those functions that are within that context will actually, access the internal context. It's a way of actually doing primitive encapsulation. Although, depending upon some people who you talk to, you might hear things like, well, this is probably the way most people end up writing their basic object-oriented systems the first time that they've done it. So in this example that I'm showing you, I am just creating a let context that will decrement and increment a counter. Those that are on the call, if I'm messing up, please feel free saying, "Oh, this is wrong," because this way.
You need to combine incf and setf.
Incf and setf.
You don't need to combine them. incf already is a setf.
Oh, okay, thank you. I've just seen code that has done it this way. So, but thank you for that. Simplifies things. Yeah, I got it. Yeah, I saw that. And the same thing I'm assuming for like F2 as well. So now, if we do an increment counter here, decrement counter, internally you can't access this counter variable at all that's around, but you have these functions that you could then, access. Of course, you can go a little bit further here and then, make a factory method that essentially gives you this ability to actually generate instances of this. And I will touch base in that factory method when we start doing more about objects and stuff, because I'm going to return back to this, even though the book doesn't actually go through it a little bit. But it's important for you to understand the nice equivalence there is with closures and creating primitive objects and even primitive structs. One thing about, did someone have a comment? Elijah, did you have a comment or? Okay. So one thing I want to bring up to some of the folks that are here, we did touch base on this in a couple of other classes, other study groups. I don't remember where, but I want to bring it up here, which is the Earmuff syntax. This is a kind of stylistic convention that's been around for years inside the Common Lisp community for global variables. Now, there is some debate, and you will see books like, particularly if you read the advanced macro tutorial Let over Lambda by Doug Hoyt, a very opinionated tirade against the use of this this notation. I don't recall the specific reasons why, but that being said, my personal opinion is it is a standard convention, and it doesn't really it doesn't hurt anything, and it makes the code very clear. You can look at a piece of code, and if you see earmuffs around a variable, you'll know it's a global variable immediately. And sometimes that is useful when you're trying to figure out the scope of a particular variable. And it's easier to do that than making sure that it's not in the function signature and so forth. Much along those same lines, there is a notation for constants. And that notation is plus. So if we wanted to make, a constant that represents pi, approximate pi, as I normally put in my code, you will if you try to set up this guy, just to show you, you'll end up getting an error because you're trying to redefine an immutable value. So But the reason I bring up this constant thing is not only should you use def constant when you're creating constants instead of def parameter or def var, but the other thing is when you are defining constants, instead of earmuffs, please use plus signs, and that will be a notation that you will see that this is a constant value. You just saw my use of actually set f, but I'm just going to mention that one notation here, just because you'll see this when you're going through the book a little more. Set f is your generalized assignment operator. You could use set f to assign any variable to another value. And just for those of you who are used to static type languages, I'm going to reiterate this. Types are not bound to the variable. They're bound to the value that the variable is assigned to. So you could set something like 5 to this global variable that I create here, and then later on, and this is a feature of all dynamic type languages, you could set it to hello, and it won't complain. You'll end up having the ability to do that. Additionally, did I assign? Yes, I do. Additionally, you can actually write multiple assignment values. It has a single assignment statement using setf, and this is kind of nice for those because you don't want to constantly see in your code multiple setfs anyway. And you could do that, and it will always evaluate to the last expression that it did the setf against. So if you try to query another global var, we have 7, and global var is set to 5. You will see in a lot of places where setf being used this way, it includes with operations. Has Wilfredo rightfully pointed out, incf and decf are your modify, increment, and decrement macros that will automatically set a value to the increment value or the decrement value that you've specified. So you could take a value like our global var, which is currently 5. And with incf, you can, increase it by 10, and it'll automatically, set to that value. So this f is a notation for set f with the increment value. It's much like, plus plus x or minus minus x in C. What else should I mention?
I wanted to mention real quick about the def constant.
Yeah, go ahead.
I know that this definitely bit me when I started working with Lisp, and so be careful with def constant when you're using like non-trivial types. So for example, like I would pretty much never use def constant on like a list, or def constant on a string is like kind of more arguable, but like anything other than just like numbers and symbols. Just because when you reload the file and it re-goes through the def constant, you might get an error about saying, hey, you're trying to assign a new value to this variable or to this constant, which isn't the same as the old value. And that's because of the whole object equality that we talked about earlier. You can kind of think of it as using, I don't know if it's defined, but equal. So if the two objects wouldn't be EQL with each other, def constant is probably going to complain. And furthermore, sometimes in my own code, when I want the semantics of a constant, but it's a more complicated object like a string or something, what I'll actually do is I'll do a def bar, but I'll still notate it with the pluses to indicate that it's a constant. But that's a stylistic thing.
That's a very good point. I hadn't thought about that particular situation just because, of course, it's and a lot of the earlier code and the code bases I've been at least spelunking, I've never seen it attempt to try doing a list. But that's a very good point. Sometimes somebody might want to create a constant list, and that's not a good idea if you're using def constant.
You actually pretty much can't, as it turns out, use def constant with a list, which is why you probably don't see it in many code bases. Because the moment you try to reevaluate the file that contains that def constant, it will basically blow up in your face and say, hey,
right.
This value is an EQL to the old value. What the heck are you doing here?
Right.
And so, pretty much no code survives that tries to do that. There's, I think, Alexandria, which is a pretty widely used utilities library in the Lisp world, has a thing I think it's called define constant, which actually lets you pick what the equality test you want to use is. And so that can be used if you do want this, do want a constant, but want something a bit more flexible than EQL.
For a more complex data structure, the use of Alexandria's defined constant might be preferable.
Yeah.
Then. Okay. Yeah. So that's a very good good point. Those of you who aren't familiar with Alexandria, I am planning on as auxiliary material to give you guys a good overview of it, just because I think Alexandria being used so often, and you will hit a lot of libraries when you guys are developing Lisp applications that leverage it. It'll be a good introduction to some auxiliary utilities that are actually basically at your fingertips. They're almost as if they're part of the standard library now, just because there's so many places that it's being used that I consider it at least a de facto standard. There are of course other de facto standard utility libraries, but we'll address this one just because it's just seen on a lot of places. So last bit here that I'm going to just touch, just simple here, which is rotate F and shift F. Now, I'm going to be honest, I've never actually used these in my own code. They are useful. I don't know if the others who are on this call, if anyone has actually leveraged shift F or rotate F, but honestly, other than this book, I've never actually leveraged it in my code. So I'm gonna be upfront.
I've only used it when I'm trying to be really clever.
Well, I use it as a swap for two arguments. Two argument rotate F is a swap operation.
Okay,
but that's like the only time I've ever used it.
So for those of you who are who are a little unfamiliar with this, rotate F basically. So if you're doing like let 5 and 6, let's say x5, y6, rotate F will be basically going to
You're not sharing your screen anymore, by the way.
Oh, dang it. That's right. That's a good let me share my screen to illustrate this. That's another. I sort of figured that I thought I was, but okay. So in this piece of code, I've set two variables, x5, y6. Then I rotate them and I create the return list. And you'll see automatically it will just do the set for you, and then you're just returning it, just like our setf before that we've seen it. It's no difference. The equivalent of this is you could just do something really dumb like this, which is if you didn't have this, you could always create a macro later on where you do let temp equals x, and then do set f x y y temp, and then you could just list them as well, and it does the same thing. But it's just a nice convenience to have it. Again, Shift is the other one that I've never really used, just because, again, it depends on what you're doing. Swapping values is it's probably already built into the library function that you guys are probably leveraging, but it is something to know about, and it does do it pretty fast. So don't write your own swap functions first unless you need to, because there are stuff that's probably available that does it for you. Probably safer too in some cases. So that's probably the lesson in this section that really that you should be familiar with. So without further ado, there's let's. This should give you pretty much everything that you need to do to actually do basic Lisp programming. All right. What we're going to start with, and what Practical Lisp is going to, Common Lisp is going to start with, is it's going to teach you some introductions to macros later on, and this is really the homework assignment for for those of you who want to continue on going on with the book, and those of you who are listening in live, I do recommend you reading this for next week. We're going to be covering the introduction to basic macros, which is chapter 7 and chapter 8. That's going to be a couple of weeks on that, just because I'll be honest, macros is a difficult subject. I want to cover not just this, but there's some supplementary material that I will post in terms of books, suggestions, and some additional things related to learning about how to actually deal with macros and debugging them. Unfortunately, this is something that this book doesn't cover too much in detail, but while we're on the subject, we may as well, take some time to actually cover it. But there are some other books that I've been reading that actually cover how do you debug macros, how do you deal with syntactic construction. But you don't need to learn, and this is something that I want to address, a lot of the rest of the of Lisp to start leveraging macros. These basic things that you learned about the syntax, functions, and variables will get you started to actually be able to leverage that. And then the rest of the other things are useful for you to actually engineer applications. But for those of you who want to learn about macros, this is the basic minimum to just start picking up macros. Any questions regarding that? Because our adventure is going to be pretty fun once we start dealing with that. I hope you guys are getting some time to actually work through the practical exercises, and I want to bring this up here into this group, and those who are watching this either live or afterwards. We are planning on going to go through, and I'm just giving a little bit of an announcement here, that to go through a couple of case studies on developing common Lisp applications end-to-end. Anybody who has some examples, apps that they wanted, think about, simple applications that you guys want to, try out and build end-to-end, that you think the study group would, not only benefit, but you will also benefit from learning about, and you want us to cover, feel free to post it on meetup.com or send me a message either on Meetup or on the Lisp Discord server where I hang out. Additionally, I am available on the Functional Programming Slack channel if you guys are willing to post up those projects too as well. But that's it for the review of this week. I'm going to leave the floor to some questions, since we have about 10 minutes, questions and some discussions. So it's up to you guys. What you guys what do you guys want to talk about at this point, based on what you guys learned?
I have a quick question about defvar.
Okay.
Since you can do a declaration without an assignment, you could obviously tell if a symbol is bound. Is there a way to tell if a symbol is declared? even though it might not be bound?
Yes, there is. I think it is.
What exactly do you mean by declared but not bound?
Right. So if you do like def var x, but you don't assign it a value initially.
Oh, I think that one's I think that's actually symbol bound p, symbol dash bound p.
Yes, I think it's symbol p.
You're not sharing your screen anymore, by the way.
Yeah, no, I am. I was just doing a lookup here, but I will.
Yeah, fair enough.
I will share it and show you guys just to make sure. So, symbol p, global var, and it will tell you whether it's a symbol or not.
Well, that will tell you if you've passed it a
actually, if we
object.
didn't intern.
Yeah, that's what I was going to ask. Does that mean that the symbol is interned but not bound?
Oh, it's bound p. It's bound p.
It's bound.
Well, but if you def var x without a value, it's technically not bound. So bound p will actually return nil. So what you're asking would essentially, I think the only like reasonable like value that you or thing that you're querying there is whether the symbol is special, because
yeah,
I mean, or go ahead.
Yeah. So, well, firstly, you need to quote the global var symbol there.
Thank you. All right. There we go. Thank you. That's what I figured. I was like, there's something I'm missing here, but I wasn't sure.
Yeah, because bound p is just a function.
Right.
Right. And so basically, you'd be passing the value of global var to it.
Right.
Unless you quote the symbol.
Right, that's correct, because it's doing a lookup to actually get the value at that time. Right. So if we did, let's do another def var here. Global var b. Okay. I do a bound on.
Yeah, that'll return false.
V. It'll return false.
Ought to anyway. Yeah.
And it does. At least in CCL, it does. In other Lisp, it should too as well.
That's standard behavior.
Right.
So now you're asking, you want to know if something has been def barred,
right? Yeah,
whether or not a value was supplied.
Right, because that's what I figured. Right, because if the thing is had been assigned, then it's bound. Right, but if you're declaring it,
right,
you're not binding anything to it, so it should be. I guess it's in the symbol table. That's why I'm wondering if is it interned and just not bound?
Well, the thing is, even just by the reader encountering it, it's going to be interned. So like right now, if he types in quote, anything, then that anything symbol is going to be bound.
So this is
like not bound, intern rather.
It's going to be interned, but it's not going to be bound.
Yeah, so intern doesn't get you what you want. What you like, the only observable behavior I think that you can get would be to test if it's special. And I don't know that you, like, off the top of my head, no, there's not a simple way to do what you're asking, but I don't know that has much meaning.
You could actually, I think I know what you're asking for. If you're asking for if the symbol exists, but there's no value associated with it, right, Michael?
Yeah. Well, yeah, because I think there are like some other things you could declare, right, like without defining them. So I was just curious, like how that, like what that mechanism was, what like the declaration versus an actual like assignment or like a definition of anything.
So there is...
So
Go ahead.
Go ahead.
Go ahead.
No. So something like the parser itself, that the reader, rather, if we're going by Lisp terminology, creates symbols on demand, right? And so just using a symbol means it exists. And there isn't really any way of talking about a symbol that you've declared but you haven't given a value per se, because, well, I guess a better way of putting it is there's no really good way of talking about a variable that you've declared to exist, because either you're talking about a special variable or a dynamic variable, which is what defvar creates, and technically speaking,
So
whether or not
this might. Sorry, I think I figured one thing. You could use find symbol, I think, to do this.
Yeah, so that will tell you if a symbol, well,
it'll tell you that if it exists, I would. Oh, right, I have to again.
You have to give it a string, actually, and you need to capitalize all the letters.
Oh, right. So I should really do this symbol name.
Well, there you already have the symbol, so there's kind of no use in finding it.
Right.
Right.
Like,
Yeah, because the moment that you have a symbol from the reader, it's findable. Just using the symbol creates it.
Okay, gotcha.
Yep.
But if you give a string there, if you do find symbol and then some string that's the name of a symbol you haven't created yet, that would be nil.
So that's
on the other hand, if you now do quote, and then in vertical bars,
you're
that's a different symbol.
This like this, right?
Yeah. Right. Oh yeah. Find symbol, take the string. My point more was that now if you rerun the string version,
Right.
Yes. Now
Then
that symbol exists.
Right.
Because you used it. Just using the symbol creates it.
Right.
The vertical bars, by the way, is just the default behavior of the Lisp reader is to upcase everything internally. That's why when you get like symbols back from Lisp, they're in all caps. Because it's internally it will read all symbols uppercase.
Right.
The vertical bars are a way of telling it basically not to do that. Anything between the vertical bars is taken literally. And you can actually put anything there. You can use have spaces between the vertical bars, and that'll be fine. It's literally anything that goes between the vertical bars just becomes the symbol name.
What you can then, obviously look up when you're doing find symbol here.
Right.
But if you want to know, so find symbol is probably what you want, but find symbol takes in the string name, not the. So if if I pass in something like in terms of global variables. I have, let's say that I say global var, which I know doesn't exist. That's how you would pass it in, Michael. Basically, you take in what you would consider to be the variable name.
In all caps.
In all caps, right.
99% of the time.
You could do that, and it'll look it up, and if it can't find it, it won't, it'll return nil. And if it found it, it'll give you two values. One is whether it's an internal symbol or if it's an external symbol. That's I never. And external symbols are basically symbols that haven't been interned in a particular package. So
without going
symbol,
right, export.
That's not into the package system yet.
Yeah, without going too deep into this all, I think the long story short version is that there's no actual way to check if something has been def barred without a value. Like there are ways using like other libraries, but as far as like just straight Common Lisp goes, there is no portable way that I know of to do that. Yeah. Because even when you find symbol, all you're doing is you're checking if that symbol was ever read by the reader, essentially, if it was ever entered.
Correct.
And
Yeah.
I mean, that's all a bunch of, that's a can of worms that you're opening there. So I just don't want to like put too much complication into this, especially because at the end of the day, it also turns out to not be very important. You will practically never see, the only times that you will see like def bars without values is when somebody's specifically using like special variables,
Right.
Which is that's its own topic.
It's a topic that I'm trying to that we will encounter, and we will discuss it at the right point in time, and that is not this current time.
Yeah, special variables they're really powerful, but you need to, they're different. In short.
So
Yeah. But yeah, the thing there is more just that like there's no really good way of talking about a symbol as being a variable but not being bound, I guess, is sort of the idea.
Okay. Sorry, I thought that was a simple question.
No, unfortunately, it isn't really, but you know.
So we're getting in on the hour here, so I just wanted to just say thanks to those of you who joined. Again, we start our macro journey next week. Same bat time, same bat channel. I will again post the Hangout on air and YouTube URL at the appropriate juncture. Just because I can't seem to, I need to figure out how to deal with scheduling logistics on YouTube Live. But until next time, thanks you guys for joining. I hope to see you guys again.
Hey, thank you.
Thank you for hosting.
Yeah.